Hello everyone, welcome to my YouTube channel. This is Filipino explaining, and if you're new to my channel, please make sure you subscribe. And without wasting time, let's look at this question on the number of photons. You have a question here. A common laser pointer produces 1.0 milliwatts at a wavelength of 670 nanometer. Calculate the number of photons produced per millisecond. Solution. So the first step, we calculate the energy of the photon. Energy is given by hc over lambda, where h is the Planck's constant, c is the speed of light, and lambda is the wavelength, given wavelength. For example, in this question, 670 nanometer is our wavelength, and this is equivalent to h f. Remember, f is equals to c over lambda. So substituting, you have the Planck's constant as 6.626 times 10 raised to power negative 34 joule seconds times 2.998 times 10 raised to power 8 meters per second. That's the speed of light. The whole of this over 670 times 10 raised to power negative 9 meters. Remember, we have converted this everything in SI units, right? So we get the answer as 2.965 times 10 raised to power negative 19 joules. After that, this is the energy of the photon. So after that, we calculate the total energy per second. So total energy as given in the question is 1.0 milliwatts. So this is equivalent to 1.0 times 10 raised to power negative 3 watts. Are we there? We multiply by 1 joule per second over 1 watt. But remember, we want to convert this into joules per second, and therefore we have 1.0 times 10 raised to power negative 3 joules per second. Okay, so after that, we calculate the number of photons per milliseconds. Number of photons per milliseconds. We calculate number per millisecond, and we have the number of photons. Number of photons is given by the total energy divided by the energy of one photon. Total energy divided by the energy of one photon. One photon. Are we there? And we have the total energy as 1.0 times 10, this one, 10 raised to power negative 3 joules per second. So we multiply by 1 photon over the energy of 1 photon, which is 2.965 times 10 raised to power 19 joules, and the whole of this. Remember now, after getting this with the energy, the number of photons, but now we want the number of photons per millisecond. So we multiply by 1 second over 1,000. Milliseconds. Remember, we are just converting. We are making the number of photons. We're calculating the number of photons per millisecond. That's why we have divided here by 1,000, and therefore we have the final answer as 3.4 times 10 power 12 photons per millisecond. Per millisecond. Per milliseconds. 3.4 times 10 power 12 photons per millisecond. Thanks so much for watching. Till next time. Bye bye.